Okay, this is a truth table using a biconditional statement. First of all, you can see that we have negated P going to biconditional. Remember, the biconditional shows going both ways. So conditional just has the arrow pointing to the right. Biconditional has the arrows pointing both ways. So this is negated P, biconditional, negated Q, conditional R. So we start off with P and Q, and then we start off with negated Q and R, and then what we do is negated Q, which would be the opposite of this column, that's where we're getting this, and then we'd have R, which stays the same. And then what we do is negated Q and R give us this column. False, true is a true, false, false is a true, 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 false is a false, false, true, true, false, false, true, 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 so on and so forth. And now we take negated P, which is the opposite of this column, so that's where we get this, and we match it with this here. So false, true is a false, false, true is a false, false, true is a false. Same thing. False, false is true. True, false. True, true is true. True, true. True, true. True, false. And that's how we got that. If we come over here, we have a couple of different terms that we need to look at. First term is self-contradiction. A self-contradiction is a compound statement that is always false. Here's an example. It says construct a truth table for the statement P biconditional Q and P biconditional negated Q. So if we look at this table, all right, here we have P and Q, which comes from our general. Here's our biconditional PQ. And here's P again. It's just the same thing as here. Here's our negated Q, which is the opposite of what we have here. And then here's our truth values here. If we have true, false, it's false. If we have true, true, true. False, false is true. False, true is false. Now we're looking at this and this. And we can see that they're all false. See, true, false is false. False, true is false. False, true, false. True, false, false. So this is the example of what we called when a truth table is all false. Tautology is a compound statement that is always true. Okay, so here's the example of a true one. Here again we have P and Q, conditional, P and Q, conditional, P or R. So here's our P, here's our Q, here's our R, here's our P and Q, here's our P or R, and then if we combine these two, you can see that we get all trues. The last one is an implication. An implication is a conditional statement that is a tautology. So an implication is going to be also all true, because that's what tautology is. So if we look at this, here we have the P or Q and negated Q going to conditional P. So again, we start with P and Q, which we know. We know P or Q. Here's P again. And so now we have negated Q. If we use this and this is how we get this. And now if we use this to here, we get this. To be honest with you, I'm not going to give you anything like this, but it's just good to know in terms of self-contradictions, which are all false, and tautologies, which are all true, and implications, which are conditional statements, which are all true. Okay?